Okay. So I'm assuming that you already, well, we have discussed the chapter 5 physically. Okay, and I'm assuming that you have done the exercise. So today's session is just to clarify a bit about the exercise. Okay, so I will put it side by side. Okay, so this is your textbooks, right? So if you look at the question start with page number 183, which is question 3A. So this is question 3A. Okay, so we don't cover A and B because remember in this textbook the coverage is more than what is discussed in the class. Remember the other sections also cover very little. So I don't think I should cover the whole thing, right? So only A is applicable to you. Now I will put another one so that when we discuss the question, you can see the working side by side. Okay. So the question is about, let me see. Okay. A survey of 34 students. So this 34 student is the total. Okay, remember, you have to know what is the total amount because normally you have to divide with the total. So that's why when you read the question, you have to check what is the total number, what is the total whatever, right? Because you want to divide with the total. A survey of 34 students at this college showed the following major. So basically this is just like their departments. So they have how many departments? 1, 2, 3, 4, 5. Suppose you select the students and observe his or her major. First question, what is the probability he or she is a management major? So what is management major? What is the number you have here, right? What is it?
6.
6.
6 over. Remember, you have to divide by the total.
34.
And then what will you get?
34.
Yes. 6 over 34, what will you get?
0.1765.
0.1765. Everyone got the same?
Yes.
Yes.
Yes, that's cool. Okay, because I don't have my calculator with me, so you better assist me with this. Okay, so remember, sometimes in the textbook, the answer at the back, they will give you 2 decimal points, sometimes 3 decimal points. For the probability to be safe, please give 4 decimal point. Okay, but in other chapters, you can just give 2 decimal. But for the probability, normally we want to see more than 2, which is 4. 4 is safe. Okay. Okay, so then we have answered the first question, right? It is straightforward. Okay, so let's go to the second question. If I go too fast, please let me know. Okay, second question is page 189, question 11. So 189, question 11. So where is this question 11? Oh, the first one. Okay, now the event A and B are mutually exclusive. Remember what is mutually exclusive? Means that these two will not be overlap. They cannot overlap with each other. Okay, they are different from each other. Okay. So basically, well, this is just like a very it's a bonus point because they already tell you that we are talking about mutually exclusive event. So if you go back to the what we call to the notes, okay. So you can see we have a mutually exclusive event. So what is the formula? Formula is probability of A plus probability of B. That's it. So for mutually event, probability of A plus probability of B. So let's go back to our question. Okay, so this is probability of A, this is probability of B. What should we do? Just plus these two, right? If let's say you want to solve with the mutually exclusive question. So let's see, what is the question? What is the probability of either, you want to know either A or B occurring? So what is the formula when we talk about mutually exclusive?
A plus B.
Yes, you want to
A
know?
plus B.
Yes, okay, thank you. So you want to know, let me use different color. You want to know either A or B. So the formula is A plus B. So your A is equals to 0.3, B equals to 0.2. So what will you get? 0.5, right? Okay, so far so good? Okay. So, second
madam.
question. What is the probability that neither A nor B? So what is this? Neither A nor B. You already answered either A or B. No, neither A nor B. Means that none of A or B. So what is this? Have you seen this before? So remember last time we are talking about the formula of A prime. A prime is nothing to do with A. Remember? Okay.
Yes. Yes.
So yeah, so if you look at the formula of A prime, which is somewhere here, where is it? Let me scroll down. This is the A prime. We call it complement rule. So what is the formula? You take 1 because the total number of probability is equals to 1. 1 minus the probability of A. Okay. So what you're gonna do is 1 minus, this is your A just now, right? 1 minus what? The one that you have computed. 0.5. So what will you get?
0.5.
0.5 as well. Okay, so far so good?
Good.
Yes.
Okay, now it's done. We have solved question 11. Now let's go to question number 13. Okay, this is number 13. Okay, I forgot your friend is here. Okay. So what is this about? A study of 200. Remember, you have 200 in total. Okay. I'm thinking. So let's open a new one. Okay, you have 200 in total. 200 advertising firm reveal their incomes after tax. So you have 3 types of firms under 1 million, 1 million to 20 million, 20 million or more. So these are the total number of firms. Remember, in total you have 200 advertising firms. So the first question, what is the probability an advertising firm selected at random has under 1 million? So you want to know the probability of just under 1 million. So how do you want to compute it? You have to take, what is it? The number of under 1 million, 1 or 2, and then divided with the total,
200. 200.
200. So what will you get? Point
5-1.
51. Remember, I don't have my calculator with me, so you have to assist me with regard to this. Okay. So the second question, what is the probability an advertising firm selected at random has either an incomes within 1 million and to 20 million or, so this is just like the previous one, either or. So these firms are different from each other, right? So this is like, what is it? What is this example? This is like what we call mutually exclusive because they are two different things. They will not overlap with each other. Okay? So, what is the formula for mutually exclusive?
PA plus B.
So this is the mutually exclusive. Remember, there are 3 different firms. So probability of A plus B. So where is your A? So A is like where is it? You have between 1 million to 20 million. So the first firm is actually, what is the probability? 61 over 200. And then you have to plus with another one, what is it? 37 over 200. So can you tell me what is it? 61 over 200, what will you get? You will get 0.305. How about the second one? You will get 0.185. So if you sum these two, remember the formula is probability of A plus B. If you sum these two, you will get
0.49.
0.49. Thank you. So far, so good? Yes. So it's done. So basically, you have answered 13A and B. So now let's move to the next question. What is it? 13 is done. 21. So 21 should be on the same page number. 21, the last part. Okay. Okay, so the last part. Okay, I think I have to open a new one. Okay. So let's read this question. A survey of grocery stores in the southeast revealed 40% had a pharmacy. Okay. So the pharmacy, let me write it here. Make it smaller. Okay. So for the pharmacy, you have 0.4. So when we talk about probability, when they said percent, you just change into decimal. So 40% has had a pharmacy, 50% had a floral. So floral, you have 0.5. And then what else? And 70% had a deli. So this deli, you have about how many? 0.7. The probability of passing both, wait, no, where is it? Suppose 10% of the store have all three departments. So these three are actually like department. So they said that suppose 10% of the stores have all three departments. So means that this is all, they have all this department, which is about 10%. Okay, so here, if you want, well, if the question asks you to draw a Venn diagram, you still remember what is Venn diagram? Okay, so you have this first diagram, second diagram, and then third diagram. So where is this 10%? It is this one. Means that these three departments are overlapped with each other. Means that they all have these three things, three departments. Okay, this is how your Venn diagrams look like. So let me put here, this is your 10%. Okay, now let's continue. Okay, so 30% have both pharmacy and deli. Now you have pharmacy and deli. Let me put pharmacy plus deli. So what is the amount? Is 30%. 0.3. What else? 25% have both floral and deli. So floral plus deli equals to 0.25. What else? And 20% have both pharmacy and floral. So pharmacy plus floral. Oh, pharmacy is P, right? Pharmacy and floral, you have 20%. Okay. So now, what is the question? What is the probability of selecting a store at random and find it has both pharmacy and floral? Where is pharmacy and floral? This is the pharmacy and floral, right? So what is the probability you will get?
Yeah.
0.2.
Huh? What is it?
0.2.
0.2. I thought that someone want to ask question. So that's why I was like waiting for it. Okay, so basically, the questions already given you the answer. Okay, that's why when you have so many information, it is best for you to list down all the information so that you can see them clearly. Okay, so the second question, what is the probability of selecting a store at random and finding it has both pharmacy and deli? You have pharmacy and deli. Hey, is it this is floral, right? Let me see, 0.25 is actually floral and deli. Oh, you want pharmacy. Where is the pharmacy and deli?
0.3.
0.3. 0.3. Okay, this one, pharmacy and deli. Okay, so next question. Okay. The event select a store with a deli and select a store with a pharmacy mutually exclusive. Are these two mutually exclusive? What do you think? Anyone? Remember?
No.
Yes. Remember, if you are talking about mutually exclusive, they shouldn't overlap with each other. But in this case, you can say that, remember, I have drawn my Venn diagram. So you can see here that there are actually overlap here. So they are actually mutually exclusive, right? If you look at Delhi and actually pharmacy and Delhi, well, you can see these, they are overlapping at 30%. So, well, of course, they are not mutually exclusive. So if they are not mutually exclusive, what do you call them? What do you call them? You will call them either, what is it? Inclusive event. Let's refer to the notes. You will call them either inclusive event or joint probability. Okay? So, in this case, pharmacy and deli, right? So, perhaps this is your pharmacy, this is your deli. So, where is the overlap? The overlap will be somewhere here. If the question asks you to draw a Venn diagram, so you should know, right? Where is the overlapping part? Okay, and the one which is not overlapping is, yeah, something here, here, and here. Okay, so next, what is the name given to the events? Oh, I think I already mentioned, right? What is the names given to the events of selecting a store with a pharmacy, a floral shop, and deli? What is it?
Inclusive event.
What?
Joint probability.
Yes. So basically, the question is just asking you this part. What is it? When they are overlapping with each other, what do you call them? This is what you call joint probability. It means that the probability are actually joining together. They are happening together. That's why you call it joint probability. Okay. The last question. What is this? What is the probability of selecting a store that does not have all the three departments? You know that when you have all the three departments, the probability is equals to this one, right? If you have all the departments, 0.1. But if, let's say, the question asks you, the store that does not have all the three departments, so how do you find this? What do you call this? Which is nothing to do with it. You have the department.
Complement rule.
Complement rule. Where is it? Complement. So yeah, that's right. Okay, complement rule. So basically, this is what you call. Let me use different color. This one. This is what you call A prime. Remember, A is something in A, but the prime means not the A. So this is like this question. You already have all, which is 0.10, but you don't want those who have all these three departments. So A prime, 1 minus the probability of A, right? So you want, what is the probability of A? A means you have all the departments, which is 0.1. So what is your answer here? You will get
0.9.
0.9. So far so good?
Good.
Okay, next. Next is question number. This is number 22. Is it 22? Oh no, this is 21. So next is question number 25, page 197. 197. So 197, question number 25, right? Okay. So I'll put it here. Okay. So a local bank reports that 80% of its customers maintain a checking account. So put it here so that you can see the information given. Okay. So checking account, you have 0.8. And then 60% have a saving account. So this is saving account, you have 0.6. And 50% have both. So this is both. Means that when you have both, what does it mean? This is the examples of inclusive event. In other words, you call it joint probability because both of some people have both account, checking and saving as well. If a customer is chosen at random, what is the probability the customer has either a checking or saving account? What is this? Remember, you are talking about inclusive. What is the formula of inclusive? If you still remember, where's the inclusive? Okay. So what is the formula? Probability of A, you plus with probability of B, minus the joint one, the overlap one. So let me put here. Let me put different color. Probability of A plus probability of B minus the probability of A intercept with B. Okay. So you have the formula here. Now, what you gonna do? Let's just write the answer. So probability of A, which is your checking account, 0.8 plus what? 0.6. Solve this first, and then you minus with the intercept one or the overlap one, which is 0.5. Can you give me the answer for this? You will get
0.9.
0.9. Thank you. So, done with the question. Is there anything else? You have another question. What is the probability the customer does not have either a checking or saving? This is like your A prime. You don't have either checking or saving. So what you gonna do for your A prime? Remember the formula of A prime? What is it? You have A prime 1 minus the one that you have computed here, which is nothing. I mean, you have to minus the A because you want to find other than A, right? So your A is 0.9. So what will you get? 0.10. Okay. So far so good? So far so good?
Yes.
Okay. So have we done with all the question? This is question number 25. Let's see. 25. Oh, we still have one more question. So page 210. Question 55. 210, question 55. Okay. Okay, what is it about? Let me read the question. In a management trainee program at these enterprises, 80% of the trainees are females and 20% are male. Okay. And 90% of the female attended college and 78% of the males attended college. So basically, you have two event here. And the second event, which is attended college, depends on the first event. First event is about males or females, right? So it's like gender. And the second event depends on the gender. Because you can see that 90% of the female, you already touched the gender, and then attended college. So the second event depends on the first event. Okay. So in this case, if you know that the second event also talk about the first event, so it's easy for you to draw the tree diagram. Although the first question doesn't ask you to draw the tree diagram, but I will recommend you to draw the diagram first. So can you help me how to do the diagram? So the first event, what is the first event? It is gender, right? So what is it? 80% are female. So this is female, 0.8. How about the male? You have the remaining 0.2. This is the first event. Second event, whether they attend college or they don't attend college. Okay. So for female, there are two probability. So this is second event, which is attending college. So I will put C as a college and C dash or slash is not attending college. So attending college for female, what is the percentage? 90% attended college. So 0.9. So how about those who didn't attend college? What is the percentage?
0.1.
0.1. Thank you. How about the males now? This is attend college. This is not attending college. So for the male, it says that 78%. So 0.78. How about those who didn't attend college? Anyone?
0.22.
0.22. Thank you. Now, once you have drawn the tree diagram, it's easy to answer the question. So what is the question? First, a management trainee is selected at random. What is the probability that the person selected is female? Okay. So you have female. What is the probability? 0.8. And then who did not attend college? Multiply with those who did not attend college. What is the probability? 0.10. So what is the value? Hmm? 0.8 multiplied with 0.10?
0.06. 0.08.
0.08. Okay, this is number A. Okay, now, second, are gender and attending college independent? Are gender and attending college independent? Independence means they are not related to each other. Are they independent? Of course, no, right? Because you can see that gender is the first event, attending college is the second event, and attending college depends on the gender. So, of course, you will say that they are not independent, they are dependent. Why? Because by looking at this tree diagram, you can see that when we talk about college, attending college or do not attending college, depends on the gender here. Okay? So, next question. Construct a tree diagram, which you have done it. But when you want to construct a tree diagram, when the question asks you to construct the diagram, well, at the moment, you can see that I didn't construct it properly. So if you want to construct it, you can put here, this is the joint probability, and then you compute the first probability. 0.8 multiplied with 0.9, so you will get here the answer, 0.8 multiplied with 0.9. So find the answer. And the second one, 0.8 multiplied with 0.1, then find the answer. So you have to compute the joint probability, okay, if the question asks you to construct the diagram. So you have to construct properly in a complete form, okay? So do the joint probability totals equals to 1? What do you think? Of
Yes.
course, right? So remember, you have the summations of all this, you will get equals to 1. Why is that? Because if you refer to your notes, let me scroll down, is rules number 6, if I'm not mistaken. Yes. So probability of any events is between 0 and 1. So 0 is the minimum. I mean, the lowest means that the probability will not happen. 1 is the maximum or the total. You cannot go beyond this, okay? So, yep, I think that's it. We have covered everything, right? Wow. Any question? I think I will stop the recording so that your recording will not be that long, because I will just cover whatever we have discussed during tutorial. Okay.